using U-substitution to find the antiderivative or to evaluate definite integrals can be difficult at times, and the difficulty of the problems can really vary. So I'm just going to do a few of the more difficult ones, which tend to be ones where maybe it's not just a straightforward U and du type of problem. So for instance, perhaps you have one where you have 2x times the square root of 5x is actually the one we did in class, isn't it? So let's do 3x minus 1. Okay, now the first thing I want you to recognize is this is a very different problem than if it was x to the 1/2 times 3x minus 1. This problem, you could actually multiply out, you could FOIL it, and then, and that'll be 6, wouldn't it? You could FOIL it and then just use the power rule to find the antiderivative. Okay, unfortunately, because that root that we have is all underneath the square root, we can't do that. Okay, so I'm going to start with u, and again, the u is typically the inside of the function, so I'm going to choose that 3x minus 1. Okay. I'm going to take the derivative, and I'm going to get 3. Okay, so I multiply both sides by dx, so this should all seem familiar. All right. So let's see what I've accounted for, right? I know that this 3x minus 1 is the u. So I have the square root of u. Okay, that's accounted for. What's not accounted for yet is the dx. So I have it here, but I do need to divide by 3. So 1/3 du will be the dx. Okay, so that makes sense. What I still haven't accounted for, though, is this 2x. Now, the 2, I'm just going to put on the outside of the integral. That's no problem. That's done. But still, this x. Okay, I need to put x in terms of u. The entire integral needs to be in terms of u to use U-substitution. So what I can do is I can actually take that original u and solve for x. I add 1 to both sides. I divide by 3 on both sides. And now I have what x is equal to in terms of u. So I can plug back in. And now it looks a lot like that problem that I was showing you in the beginning, how this problem was different than that. Right now, it's something that you can simplify. So the first thing I'm going to do, the 1/3 times the 1/3 is going to be 1/9. I'm going to bring that out and leave it with the 2. I'm going to write the u as u, the square root of u as u to the 1/2. And then I still have the u plus 1 du. Okay. Now I can FOIL. So I still need, remember, I don't have that reverse like product or whatever. So I do need to multiply this out before I can find the antiderivative using the power rule. And very reasonable. Okay, now I can take the antiderivative. Remember, that was the whole purpose of substitution, was to make what was inside the integral easier so that you can find the antiderivative now. So I get u to the 5/2 plus 1, divide by the new power, add 1, divide by the new power, plus c. Okay. So your last step, again, remember, I introduced the u. You need to make sure that then the du, that your original function is in terms of x. So x, the u was 3x minus 1. So now I'm just going to go back and plug that in. So 3x minus 1, I feel like I'm going to forget it. 3x minus 1 to the 5 halves. You can see I flipped the fractions just to make it easier for myself to simplify. There's really not much else you can do to make it any simpler than this. I hope this was helpful.